Okay, the very first section is gonna be about IPv4 address overview. If you're comfortable with working with IPv4 addresses, you can just skip this section. But if you want to know how to convert binary to decimal and vice versa, I want to give you some very nice tips here. So first of all, you know that IPv4 is a 32-bit number. So we have 2 to 32 different possibilities for this, but of course we cannot use all of them. I'm going to talk about this later, but you know that we show them in sections. So we have the 1, 2, 3, 4, 5, 6, 7, 8, and we put it in one octet. And of course, the same happens in the next section. So 1, 2, 3, 4, 5, 6, 7, 8. This is the second octet. 1, 2, 3, 4, 5, 6, 7, 8. This is the third octet. And of course, 1, 2, 3, 4, 5, 6, 7, 8. This is the fourth octet. So each octet consists of 8 bits, and this is just to show you that I'm dividing this into 4 octets just to make it easier to understand, of course. So why would we divide it into octets? We actually wanted to convert to decimal numbers. So we know that decimal values of each bit is shown in decimal, notation. What I'm going to do is to show you how you can convert this into decimal so that you can easily work with the IPv4. So I'm talking about just one octet, but you can, assume that all of these octets have the same 1, 2, 3, 4, 5, 6, 7, 8, the same 8 bits, and you can of course apply it to all of these octets. So first of all, I want to assign a value to each of these bits. If I start from right to left, this bit has a value of 1. Let me write it in red. This bit has a value of 1. This bit has a value of 2. This bit has a value of 4. This one has a value of 8. This one has a value of 16. This one has a value of 32. This one has a value of 64. And the last one has a value of 128. So if I want to turn this on, I should assign this value to that. If I want to turn it off, it has no value, so it is going to be 0. So if I want to convert binary into decimal, I need to, just sum up all of these values where those bits have a value of 1 or where those bits are on. So let me give you an example. Assuming that I have this, let me change my pen. They have given me this value 0. Oh, this is so fine. I need a thicker pen can be fine chisel. Okay. Working in journal so that I can save all of this for you. You can just refer to this later. So assuming that I have 0, 1, 1, 0, 0, 1, 1, 1. They give me this binary value and they ask me to give them the actual decimal value related to this. So what I need to do is to convert these values into decimal. I want to assign those values to them. So the first bit from right is off. It doesn't have anything, so it is 0. I just put a plus here. The second bit is on. You know that from right, the second bit is going to have a value of 2. So I add 2 to this number. Again, this is on and it has a value of 4. So I write 4 here. This is off, so it has no value. This one is off, it has no value. This one is on, so it has a value of 32. The other one is on, so it has a value of 64. And this one is on, so it has a value of 128. So if I sum up all of these values, I have 192, 224, 228, 230. So it's going to be 230. So if I want to show you that I am right or wrong, I can just go to calculator, go to programmer mode. In programmer mode, just go to binary mode and type this 111001110. And if I click on decimal, you can see that it is 230. So this is exactly what I have got here. So you have a very nice skill to, change the binary to convert the binary into decimal. So let me give you another example. You should just memorize these values. These are the values related to 8-bit, so you should be completely comfortable with these values. So let me write another example. They give me a binary value like this: 100000001. So they ask me to give them the decimal value for this binary value. So I start with this. You know that from right, the first bit is on, so it has a value of 1. The other bits are off, so they all have zeros. And I have the last bit that is on, and you know that this bit has a value of 128. So the value is gonna be 129. So let me check this in calculator and see if I'm true. Go to binary. Want to drag this to the left. I type 1, 1, 2, 3, 4, 5, 6, and another 1. So if I go and click on decimal, you can see that this is 129. So now you know how to convert binary into decimal. What if I want to convert decimal into binary, and I want to show you how I can do this? So assuming that they give me the value of 191, and they ask me to convert it into binary, how can I do this? What I need to do is to remember the value of different bits. I have 128, I have 64, 32, 16, 8, 4, 2, and 1. So I know the value of each bit, and what I need to do is to reduce this value from the actual decimal number that I have. So if I look into 191, I ask myself, do I have a 128 in 191? Of course I have. So because I have this, I just put a minus sign here, and I put a 1 here. So I have 1. Let me write it again. This is a little quart to work like this. So 191 minus 128. So if I write this, is gonna be a 3 and a 6. So we have a 63 here. Do I have a 64 in 63? Of course I don't have. So I just put a 0 here and move this down. So do I have 32 in 63? Yes, I have. So I put a minus sign here, and 32 is going to be a 1 here, and we have 31 left. Do I have a 16 in 31? Yes, I have. So I put a minus sign here, and I put a 1 here, and the result is going to be 15. Do I have an 8 in 15? Yes, I have. So I put a minus sign here. Here I want to turn this bit on again, and the result is gonna be 7. So I have a 4 in 7, again the same thing, and the result is gonna be 3. I have a 2 in 3, so this is going to be on again, and the result is gonna be 1, and I have a 1 in 1, so this is going to be 1. So we have actually 1 0 1 1 1 1 1 1. So let me go to calculator and see if it is true. I want to type 191. I want to see the binary value related to that. It is 10111111, exactly what I have got here. Okay, let me give you another example. So I need to add a page to my journal. They give me this value. They tell me you need to convert, for example, 113. Okay, so what I should do is to remember the number again. So I have 128, 64, 32, 16, 8, 4, 2, 1. And you know that these are all, multiples of 2. Okay, so I start by doing this. Again, let me change my pen. I know that I do not have a 128 in 130, so I just put a 0 here and move my 130 down one level. So I have a 64 in 130, so I put a minus sign here. The bit is going to be on, and if I want to, it is going to be a 9, and 677 is going to be 49. Okay. So, do I have a 32 in 49? Yes, I have. I hope the math is correct because I'm not very, good in math. So I have a 1 here, and 32 from 49 is going to be 17, I guess. Do I have a 16 in 17? Yes, I have. So I put a minus sign here. This bit is going to be on again. And the result is going to be 1. There is no 8 in 1. 1 goes down at the 1 level. There is no 4 in 1. So again, 1 goes down. And there is no 2 in 1. 1 goes down. And we have a 1 in 1. So this bit is going to be 1. These are zeros because we have nothing in 1 equal to 8, 4, or 2. So the result is going to be 0, 1, 1, 1, 0, 0, 0, 1. Let me check this out. So if I go and type 130 and go to convert it to binary, so we have 111, actually, do you see that? And we have 0001 and 0001. This is the conversion from decimal to binary. And now you have enough examples to, you get the idea. You know how to do this. And it is very easy to work with conversion from binary to decimal. Okay, next section I want to talk about different, let me write it in, different classes. Okay, I want to talk about different classes of IPv4. And I want to show you what happens in binary that makes those numbers that we have to memorize, and they are gonna be so hard to memorize, of course. But if you know the actual mechanism of IPv4 addressing, you can easily guess what is the starting number for IP class A, what is the end number of IP class A, and of course for all classes.